Good evening to all the viewers. Let me start to explain the performance criteria of automatic elevator doors. Next slide, please. So in this, the first aspect we will see related to automatic door obstruction detection. So actually, part of automatic door function is to ensure that the door should not close if there is any obstruction. And once it is detected, and it has to be immediately retracted. And also this is ensured by having a elevator car door sensor, which is basically functions as a obstruction detection, and this prevents the door from reclosing. And once the door doesn't reclose, the elevator also remains stopped. So this this can be done with the three different types of sensors. One is photoelectric. It is actually a 2D kind of sensor with the two different sensors fixed at the bottom of the doors. As you can see at the first picture, there are two different lines. This is actually an infrared sensor, and these are located at a predefined location. So when a person or a user is trying to enter from landing to car door, and the doors are open, and in case of any obstruction, the landing door and car door stops movement, and it does not allow to get the user stuck in between or crushed in between. And the next sensor is a little advancement from the basic one. It is considered, it is called as a 2D beams, and this has a little more advanced features like the sensors is actually placed at two sides, and this is this ensures that there is a crisscross kind of beams passing from one side to the other side, and this ensures a little more safety rather than having just two sensors at the bottom level. And the more advanced sensors are 3D sensors. This actually typically detects not just when a person is just trying to enter, it will also detect a predetermined layout or an area. So this car door sensor is always fitted to the automatic car doors in every installation. So this is a kind of a safety feature also, we can say. Next slide, please. Mr. Tak, you can pause the video. So the next important aspect of an automatic door is this is also tested for impact resistance. Automatic doors are tested based on prevailing elevator standards. For as my colleagues have previously explained, for different regions there are different elevator standards, and each elevator standard prescribes what should be the impact resistance. And this also has to be ensured that even after impact, the door should not come out of the elevator sill, and also it has to act as a barrier so that the person it will avoid the person's falling into the elevator shaft. So I have a small video which took place in the past years. Mr. You can play the video. Mr. You can pause the video. So here you can see, though this incident could have been avoided, but this is the reason why even if a user tries to kind of vandalize or show his frustration due to unknown reasons, all the elevator automatic doors, landing doors, and car doors both have been tested for impact resistance. And you can see at the left side, the first image shows a pictorial representation of how what happens after an impact. Even after the impact, the door does not open, and also it does not allow any users to fall into the shaft. And the second image shows how a typical impact test is done in the laboratory when the door is designed and tested. So this we have a pendulum type of arrangement, and this, for example, for EN standards, the steel doors require a 45 kg impact test to be performed at the mid-level. It is actually performed at the weakest section, which is actually the mid section of the doors. And also, after the test is performed, a deflection described in the standard has to be ensured. Even though the door doesn't come out of the guiding elements, if the deflection criteria exceeds, then even then it is considered as a failed design. So it's both impact and as well as deflection is very important. As you might have seen the video, if the door was tested for this impact resistance, at least the user would have not had to undergo the unfortunate event. Next slide, please. So here I'll explain about the performance aspects of the automatic door. So the right side image is a brief layout of the parts of an automatic landing elevator door. One is the mechanism. The second is the structural part considered as two uprights or vertical frames, and the horizontal one is considered as a lintel or a horizontal frame. And the next one is the moving elements, is the door panels. And these door panels are guided at the bottommost section in the component, the subcomponent called the sill. And the last one is related to toe guard. This is the basic layout of the automatic elevator landing door. And you can see each subcomponent is actually tested for both mechanical tests, electrical tests, durability tests, and also the fire test. So whenever a door system is designed, all this checklist has to be ensured, tested, ensured, certified, and then only it is released to the market. So the detailed testing of the subcomponents I'll explain in the next slide. So apart from this automatic elevator doors, it is also considered as a silent operation. This is also ensured by performing a noise test in an anechoic chamber. And the basic difference between manual door and automatic door is, in manual door you have to touch the doors to open. So whereas in automatic doors it is all controlled by the system, so that the user doesn't have to touch it. So that is why it is considered as a touchless entry. So the final takeaway of this slide is, performance and safety can be ensured only through defined test and certification. Next slide, please. So here, this is related to the landing door mechanism. And here, basically, we are checking the lock integrity. Landing door lock actually prevents the door from being opened manually. And this door lock is actually a very critical component, as this assures safety in automatic doors. And apart from the mechanical lock, there is also an added safety through an electrical switch. So whenever whenever a landing door lock is open, the safety switch also is activated, and this sends a door signal to the controller saying to stop the lift movement or the elevator movement. And the right side, you can see first is the mechanism, and the rectangle part highlighted is actually the switch and the mechanical lock. So hence the reliability and the quality of the door lock and switch is extremely important. And this is ensured in automatic doors is by getting a CE certification. Actually, a CE certification is a third party or certified external laboratory which ensures or witness the test performed by the manufacturer after providing the design details and also the test reports. They go through a critical check, and even after a critical check, they mandate us to do a retest of the entire landing door lock in front of them, and then only they provide a CE certification. And every landing door lock of the product has a unique CE certification number. Here in the last below image, you can see a CE certification label pasted on the landing door lock. This actually provides a peace of mind to the user, and also ensures saying that this apart from the manufacturer's claim of tested locks, even a third-party accredited laboratory also certifies that this landing door lock is safe. And apart from that, every year this CE certification, the auditor visits the manufacturing plant, performs a critical quality check of the components, and then only it is renewed on a periodic basis. It is not like just one time a door is designed, tested, and certified by a third-party laboratory, and it's forgotten. It is actually a periodic renewal process. So this stringent certification of CE certification actually differentiates between a good and a bad quality door lock system. Next slide, please. So here, this explains the second criteria of a door panel system for deflection resistance. In that, the first criteria is ensuring the gap between two door panels. Let's say for a condition where during maintenance of elevators, where untrained technicians or for an unforeseen reason, end user is trapped inside an elevator shaft, and when they're trying to exit, they try to pull the doors manually to get untrapped themselves. This is actually a risk to the both the technicians and also the users, being since there is a landing door lock provided in the automatic elevator door system. By pulling through hands, the gap between the door panels, though you can see a wider gap, people can try to get stuck in this between gap, and when this gap people get stuck, still the door panels are intact at the top, because there is a landing door lock which is preventing the doors to open, and this in terms considers the elevator system that the doors are closed and the car can operate. But for this reason, there is a special kind of test according to EN or IS or even American standards for different criteria, where a predefined load is applied at the bottommost panel and the midsection of the panels. And this actually simulates this environment, and it has to fulfill the deflection criteria. And the next thing is related to a gap between a door and a frame. This right side representation picture, you can for the benefit of public, they might have come across this kind of scenarios. So to avoid this during testing, there is a deflection deflection criteria mentioned in the elevator standards to ensure that the gap between a moving door panel and a frame does not exceed the norms. This thereby prevents the severance of fingers of kids or elderly people, which accidentally gets trapped between the door and the frame. So if this is tested according to the defined elevator standard, this ensures that this kind of accidents or incidents doesn't happen. Hence, adherence of the door panels to specified safety standards is extremely important. Next slide, please. So here, this is again a deflection criteria resistance, but it is to different subcomponents. Right now, we'll focus on the elevated door sill. You can see in the first image with the blue arrow marking, and this is actually considered, this is called as an elevator sill. So the elevator sill has a primary function to withstand the deflection caused by people and material movement for the period of 20 to 25 years of time for which the door system is designed. So a weak sill, actually, if it deforms, and it can form a trip hazard. So when people entering or exiting the elevator can fall either direction, and it can cause a serious injury to end users. Hence, elevator door sills must be thoroughly tested and ensure that the deflection is within the prescribed standards. And in this testing also, there are different guidelines or different set of criteria to be followed. One is a static load test, and another one is a dynamic load test. In static load test, the worst case load is applied on the sill for a predetermined timeline, and after a predetermined timeline, the deflection of the sill is measured. And in dynamic case, simulated a trolley kind of arrangement with the maximum load is applied, so that it is actually simulating material movement from landing door to car door and car door to landing door. These are simulated for a predefined cycles, and then the deflection criteria is not just measured at the bottom. These are measured in the 3 directions, X, Y, Z, and directions. So as I said earlier, this also is a very critical aspect, and automatic landing door system has to be tested for this basic test. And in the right side, it is related to the toe guard, where technicians, when they're working on an elevator maintenance, there can often be situations where the car is at a different level and the landing is at a different level. So at such times, there is a tendency for the technician's foot to fall in the gap between car platform and the landing floor. So a toe guard actually prevents this incident to happen, so that the technician's foot does not fall into the gap. So here at the bottom image, you can see the right side. When you see from the right side, a person who is trying to get into the car, since there is a toe guard, there is a tendency for the leg to swing between the car platform and landing door floor. And if there is no toe guard, and if the car accidentally starts to travel, again, there can be a serious fatality or injury by severance of foot or limbs. So it is important that the toe guard also has to be tested for a deflection test specified as per the standard, and it has to be complied. All these tests are specifically to ensure that the user safety is kept in mind. So as I said earlier, in an untested toe guard or untested door sill, or even the landing door lock or the impact, it is all designed, tested, and installed and maintained for the lifetime of the period, to ensure the users doesn't have to face these incidents. Next slide, please. So I'll hand over this slide to Mr. Giuseppe.
Good afternoon, everyone. Let's see together what happened when a fire occurs in the building and how the elevator is involved. So let's start with what is characterizing the door and the fire resistance, and why it is useful to have a fire resistant door in buildings which are sensitive to the event of the fire. Next slide. Thank you. So what happens when a fire enters and occurs in a building? Usually the fire tries to go around the building, and it spread horizontally and try even to go upwards and downwards. The shaft of the elevator is one of the fastest way of the fire to climb the building and to come from one floor to another floor. So the fire usually try to enter in the shaft of the elevator if there is the possibility. For this reason, in certain buildings, it's required to have fire resistance doors in order to avoid the spreading. In particular, usually when the building is more higher, the protection required has to be even higher. There are different kinds of door. The resistance of the door to the fire can be for a certain time, depending on the time it has been able to pass the test. Usually the typical resistance of the door is 60 minutes, 90 minutes, or 120 minutes. What does it mean? It means that if the fire arrives to the door of the elevator, the door will stop the fire from spreading for this time, which is the certified one. The automatic door typically are provided with the possibility to have it fire rated. The manual door, usually they don't have fire resistance. So let's skip to the next slide. Which are the regulations existing in the world and which are important to certify and qualify the fire rating resistance of the door? Today, there is the EN8158, which is used in Europe, mainly, but even in other countries, typically around the world. Then there is BS476, which was the norm coming before EN8158, which is still used in some countries, typically even in India or other Malaysian country, but is disappearing step by step. Then there is UL10B, which is typically used in North America and some country around the world. And then there are other GB standard, which is the Chinese one, which is locally used, and IS 38093614, which is the Indian standard used for certifying the fire resistance locally. The classification of the fire resistant door can vary depending on the fire resistance that we want. Typically, E is indicating integrity, so the door is able to stop the fire from passing through the door and entering in the shaft. EI is insulation, so we stop the fire not only from passing through, but we insulate the internal of the shaft from the temperature rising. And then the last one is EVU, which is the protection not only from the fire passing through, but even from the radiation of the fire. Duration, as we said before, typically 60, 90, and 120 minutes. Which are the parameters that a door has to fulfill to be able to pass a test, so be able to fight against the fire? First of all, the first parameter is sustaining flaming on components. The second is gap gauge measurement, radiation flux, gas leakage, and fire hose stream. Now we will go deep into these key parameters. Next slide, please. So the first one, usually a fire impacting a door will transfer a big temperature to the door itself. The component has to resist to this temperature and has to be able not to let the fire go to. So if the fire is able to go through the door or to fire one of the components, if there is a flaming, continuous flaming for more than 10 seconds, then the door cannot be fire certified. What is important, why this is important, is because if the fire is able to pass into the shaft for a certain time, there is a high probability that it will spread within all the components that are inside the shaft. Typically, the fire is like a monster that tries to spread around the building. Next slide, please. What happened to the door during the fire event? The door, due to the fire, will start deforming. The deformation is a normal in every metal, in every kind of material affected by the fire. So the steel, the stainless steel, and all the different material used to build the elevator, if they get very hot, they will try to deform. it is important that this deformation do not allow the fire to pass through. So it is important that during the fire, there will not be spot or gap between the door element that let the fire enter in the shaft. For this reason, during the fire test, it is monitored this happening, and it is a failure if a rod of 6 millimeter or 25 millimeter is able to pass through the door. Because if one of these elements is able to pass through the door, it means that the fire will pass through. Next slide, please. Another protection that has to be, may be required to resist from the door is the radiation. Maybe the fire is not able to pass through the door, but we don't want that the people in the shaft or in the car are affected by the temperature, the radiation of the temperature of the fire. For this reason, there is this test, which is tested by sensor, where we detect how much radiation is passing through the door during all the time. The radiation has not to exceed 15 kilowatt for square meter, because this is the limit of tolerability by the human being. Next slide, please. Okay, this is an important news starting from the 90s. More the buildings were becoming taller. You can take as reference, for example, the Imperial Towers in Mumbai. More is not only the fire that can bring issue, is even the gas or the smoke generated by the fire. You can imagine in a big tower that on an intermediate floor, there is the vent of the fire. All the people which will be in the higher level of the building will be blocked by the fire. But maybe the fire do not arrive to them, but all the smoke and the gas will go up and create disease, or will even make the people not be able to breathe and die. This is why the latest test methodology include the gas leakage rate detection. It is not allowed to a percentage, a quantity of gas exceeding 3 cubic meters for minutes to pass through the door. It is not taken into account the 14 minutes when the test starts, because it is the period where all the water that is inside the door will create a kind of smoke, but this smoke is not lasting for a long time. It will last until the water will disappear. Okay, so this is very important for the evolution of the elevator and the evolution of the fire protection, because the buildings are becoming taller and taller. Next slide, please. This is a test that is typically done with UL10B, applied in America in particular, as I said before. So what happened in the building? Usually it starts the fire. There is a lot of panic. The fire spread along different floor, and then arrive the firemen. The firemen enter in the building with when there is a lot of smoke, and he starts with the water pump to try to solve the spreading of the fire and try to extinguish the fire. There is a problem that maybe there are people which are inside the shaft or which are in the elevator car. these people need to be protected by the firemen breaking through. So if the firemen try to extinguish the fire with the water pump, it has not to be able to break the door and reach or hurt the people which are in the elevator car or in the elevator shaft. This is very important. It is not applied on all type of fire rating, but it is giving an additional safety to the people inside the elevator. Next slide, please. Okay, the Indian elevator standard is usually mandatory when the building is more than 15 meters in height. So basically is more than 3-4 floors. Usually the manual door are not fire rated. So in case of fire rating, an automatic door is suggestible. There are accredited fire laboratories which are around the world and very famous that can certify and qualify the door to be fire resistant. The fire resistant has to be certified. There is no any fire resistance which is recognized in the market if has not been certified by a notified laboratory. The classification, as I said before, are E, EW, EI. So E only integrity, EW integrity and radiation. EI, it means integrity and insulation. And EI door is even for default radiation protected. So if you want to have an insulation, you immediately get even the radiation protection. The duration is typically 60, 90, and 120 minutes, as said before. Next slide. Glass. Usually, as reported in the Indian standard, the vision panel should not be provided on power-operated door. So usually they're not provided, and usually the door with the glass are predominantly not fire rated. There are, in any case, door which are having a glass fire rated, so that they can assure a certain resistance to the fire. This is an option, this is a variant that is available in the market. Obviously, even in this case, the fire rating has to be tested and qualified by a certification body. The fire rating glass is not a common glass, so is much more expensive than a normal glass, but is even assuring a very high protection. Next slide, please. Here is a summary on the future standard. So today, one of the main and the most famous standard available in the global market is the EN81 2050. In the future, there will be ISO 80100, which will be globally applied. So there will be an harmonization of all the safety requirement for elevator globally. The elevator is not different worldwide. All the elevators should assure the same safety level and the same protection. So we expect in the future to have one common standard that can be applied everywhere. This will have some exception because the interface to the building and the fire protection may vary depending on the country and on the building code. But we'll assure that there is a most easy certification of the product among country because the solution will be recognized worldwide. And it will be possible to have a global free trade. So it will be possible from India to export very easy because the solution will be recognized worldwide. The goal is to have one product and one norm worldwide.